All right, let's dive into one of the biggest questions you can possibly ask. Just how many galaxies are out there in the universe? For a long, long time, we thought we had a pretty good idea. Turns out, we weren't just a little bit off. We were off by a mind-blowing amount.
For decades, scientists were pretty confident they had a solid answer to this question. But then, a completely new way of looking at things just blew our old cosmic census right out of the water. So, what's the real number?
Okay, brace yourself for this one. The number we've all been quoting for years, somewhere between 100 and 200 billion galaxies, was wrong. And not just a little wrong, it was off by a factor of 10. The new reality, our new estimate, is 2 trillion galaxies. That's not just a minor update, that's a complete rewrite of our map of the universe. 2 trillion. Just let that number sink in for a second. 2 trillion. To try and put that into perspective, our own Milky Way has maybe 200 billion stars. So you multiply that by 2 trillion galaxies, and well, the total number of stars in the universe just becomes something you can't even really wrap your head around. This is our new baseline.
So wait a minute, how did we just suddenly stumble upon more than 1.8 trillion new galaxies? Did we launch some secret, ridiculously powerful new telescope? Well, no. The answer is actually so much more clever than that. These galaxies, they were kind of hiding in plain sight, deep inside old data. It all came down to a brand new way of looking at it.
That's right. Back in 2016, a team led by Christopher Consolis decided to revisit some of the most famous images in astronomy, the pictures from the Hubble Deep Field. But they didn't find these missing galaxies by just squinting harder at the picture. They found them by getting creative with the math.
So here's the game plan they used. First, they took Hubble's deepest, most detailed images and used them to build 3D maps of all the galaxies we could see. Then came the really brilliant part. They created a mathematical model to figure out, or extrapolate, how many more galaxies were out there that were just too faint or too far away for Hubble to even register. And then, for the final masterstroke, they essentially rewound the clock. They calculated how many tiny, ancient galaxies must have collided and merged over billions of years to create the bigger galaxies we see today. Once they added all those ghost galaxies back into the equation, boom, the number just exploded.
But look, this isn't just about getting a bigger number to feel impressive. This new, massive count actually helps solve some really nagging problems in cosmology. It makes our big picture theories about how the universe works, well, it makes them fit together a whole lot better.
For years, there was this big headache for cosmologists. Our best theories, especially the ones involving cold dark matter, predicted that there should be way more small galaxies out there than we could actually find. It just didn't add up. But this new 2 trillion galaxy count, it makes the observations line up almost perfectly with theory. Suddenly, the math works. It also helps explain that incredibly intense burst of star-making that happened in the early universe simply because now we know there were way more galactic nurseries for those stars to be born in. Now, as incredible as 2 trillion is, believe it or not, the story doesn't stop there. In fact, astronomers are almost certain that number is still too low. Our census is always limited by the tools we have, and the next generation of tools is already out there, peering even deeper into the darkness.
Yeah, this is the really crucial thing to get. 2 trillion is the floor, not the ceiling. It's a lower bound. Hubble is an amazing machine, but it has its limits. It can't see everything, especially the most ancient, most distant, or dustiest galaxies. But we now have an instrument that can.
And that's where the James Webb Space Telescope comes in. Because Webb sees the universe in infrared light, it can do two things Hubble can't. It can peer right through clouds of cosmic dust, and it can see the faint, stretched-out light from the very dawn of the universe. As space expands, the light from those first galaxies gets redshifted way down the spectrum, and Webb is designed specifically to catch that light. It's already looking further back in time than we ever have before, to just a couple 100 million years after the Big Bang.
And what's so wild is that Webb isn't just confirming what we thought we knew. It's finding things that are genuinely shocking, like galaxies in the early universe that are way brighter and more massive than our models thought was even possible. Every single new image seems to hint that there's even more out there and that our final galaxy count might climb higher still.
Okay, now I want you to zoom your mind all the way out. Because everything we've been talking about, every single one of those 2 trillion galaxies, exists inside a very specific, very important boundary. And thinking about what's beyond that boundary, well, that leads to one of the most profound ideas in all of science. It's so important to remember this. All 2 trillion of these galaxies are inside what we call the observable universe. Now, this isn't some physical wall at the edge of everything. It's just the edge of what we can see. It's the bubble of space whose light has had enough time, 13.8 billion years, to finally reach our telescopes. We are sitting at the very center of our own personal cosmic bubble. So the obvious question is, what's outside our bubble? Our best theories, like cosmic inflation, strongly suggest that the true universe is vastly, unimaginably larger than what we can see, maybe even infinite. And if that's true, then our 2 trillion galaxies are just one tiny, insignificant patch in a reality that literally goes on forever. That is a truly humbling thought.
And of course, this all leads us to that ultimate, haunting question. If there are 2 trillion galaxies, each one filled with billions or even trillions of stars, and many of those stars have planets, if the stuff of life is everywhere, then where is everybody? This is the famous Fermi paradox, and a universe with 2 trillion galaxies just makes the silence, the great silence, that much louder.
So in the end, 2 trillion isn't just some big number. It's a measure of our place in the cosmos. It feels like every time we manage to build a better instrument and look a little deeper, the universe just gets bigger and grander and way, way more mysterious. This isn't the final answer. It's just the latest step on a journey that reminds us, again and again, just how much more there is left to discover.